Welcome back, Focus Learners. Today, we're looking at something so common you probably walked past one this morning without even giving it a second thought: flowers. Together, we're going to break down their hidden biology, explore their absolute evolutionary genius, and uncover exactly how they've shaped human civilization. Let's get started. Okay, let's dive into this. When I ask you why flowers exist, what really comes to mind? For a lot of us, we instinctively think of a beautiful vase on a dining room table, or maybe a super colorful garden display. We kind of just think of them as these pretty, delicate decorations placed on Earth for our viewing pleasure. But nature doesn't expend that kind of intense energy just to make something look nice for us. There is a deeply practical, absolutely necessary reason for their existence. Here is the biological reality. A flower is not just a pretty face. It is a highly specialized, finely tuned reproductive factory designed to sustain plant life. Literally everything about them, their color, their shape, their size, their smell, it's all an evolutionary adaptation built to ensure the survival of their species. They are nature's beautifully disguised survival mechanisms. So here's our roadmap for this explainer. First, we'll look at where flowers bloom. Second, we'll dive into the science of scent. Third, we'll break down the anatomy of a flower. And fourth, we'll look at how humans use them. Section 1. Where flowers bloom. Plant adaptability. You know, one of the most incredible things about flowers is their sheer adaptability. I mean, they don't just exist in carefully curated gardens. Look at the range of categories here. You've got towering trees like the gulmohar and the famous cherry blossom. Down at eye level, you have sturdy bushes giving us roses and jasmine. Then you've got creepers like the morning glory, literally winding their way up structures. And of course, aquatic environments aren't left out at all. Water plants like the lotus and lily have adapted perfectly to living in the water. This incredible diversity really grounds their botany in almost every single corner of our everyday reality. Moving right along to Section 2, the science of scent, chemical signals. Now, what's really interesting about this slide is the sheer contrast in survival strategies. When you lean in to smell a flower, you're actually interacting with a highly targeted chemical signal. On the left side here, we have the sweet, strong allure of roses, lilies, and lavenders, which are deliberately emitting chemicals to attract specific insects. But on the right, this is where evolution gets extreme. The giant titan arum and the Rafflesia, which, by the way, happens to be the world's largest flower, emit a foul stench that smells exactly like rotting meat. No way, right? But why? Because they aren't trying to attract delicate bees. They are actively luring in carrion flies and beetles to do their reproductive heavy lifting. But nature always finds alternative strategies. Some incredibly successful flowers, like orchids and sunflowers, are almost entirely unscented. They rely on visual cues rather than smell. Then you've got the fascinating shift workers of the botanical world, the night bloomers. Flowers like the evening primrose and the moonflower open exclusively in the dark. They are specifically targeting nocturnal pollinators like moths and bats. It's brilliant. Section 3. Anatomy of a flower. Reproductive engines. Let's zoom in close now and actually look at the mechanical parts of these engines. The outermost layer is the calyx, which is made up of sepals. Think of this as the flower's protective armor. When the flower is in its really young, vulnerable budding stage, the calyx acts as this tight shield against the elements and predators, totally guarding the delicate machinery that's growing inside. Once that armor opens up, you get the corolla. That's really just the collective term for the petals. I love to think of the corolla as the glowing neon signs of the plant world. They're bright, they're colorful, and they are purpose-built to lure in those essential pollinator workers, all while serving as a secondary layer of protection for the inner organs. And what are those glowing neon signs actually protecting? Well, the internal reproductive engines. The Androecium is the male reproductive part of the flower, while the Gynoecium is the female reproductive part. These two distinct components sit right there at the center of the petals, totally ready to get to work the moment a pollinator arrives. So the crucial point here is the physical transformation. Think about it. You start with a bud, a small, closed structure wrapped tightly in its calyx armor. Then it transforms into the flower, a large, open, spread-out structure displaying its corolla and internal engines to the world. It's a really brilliant shift from a closed, protected system to an open, actively reproducing one. And this dynamically illustrates how all those anatomical parts work together in chronological order. Step 1. Those colorful petals of the corolla attract the birds and bees. Step 2. These pollinators dive in and unknowingly carry pollen from the male Androecium of one plant to the female Gynoecium of another. Step 3, mission accomplished. The plant successfully produces fruits and seeds to guarantee the next generation. It's literally an incredibly efficient assembly line. Bringing us to section 4, how humans use flowers, practical and emotional. Let's zoom all the way out now. Humans have recognized the properties of these botanical engines and completely co-opted them for our own survival. And it starts right in your pantry. I mean, we eat flowers constantly. Valuable spices like saffron, that comes directly from the crocus flower. Cloves? They're just dried, fragrant flower buds. And as for actual food, things like cauliflower, broccoli, moringa, these are literally flowers. We even make sweet preserves like gulkand out of dried rose petals. And this botanical utility spills right over into our sensory and artistic lives too. Those targeted chemical scents we talked about earlier, we extract them as essential oils to make perfumes, soaps, and incense out of lavender and jasmine. And those bright neon colors used to attract bees, we harvest them as natural dyes from marigold and hibiscus to paint, color our clothes, and celebrate festivals like Holi. But the power hidden within these delicate petals goes way beyond cooking or art. It's actually pharmaceutical. Since ancient times, humans have used flowers as highly effective medicines. Calendula petals are turned into healing ointments for skin burns and cuts. Rosewater has long been used to relieve eye irritation, and chrysanthemum petals are steeped into a hot tea specifically to reduce pain and fever. Finally, despite knowing all this complex biology and the practical utility, we still fundamentally rely on flowers for a really profound emotional and spiritual connection. We use loose flowers like marigolds and palash as offerings during prayers. We bundle them into bouquets as gifts to express love or sympathy. We string them into torans or arrange them into rangolis to decorate our home entrances during festivals. They are just deeply, deeply woven into the human experience. So what does this all mean? Here's my final thought for you. Next time you walk past a garden or look at a bouquet on a table, what will you see? Will you just see a pretty little decoration? Or will you see an incredibly adapted, highly evolved, ancient life-sustaining engine that feeds us, heals us, and literally ensures the continuation of life on Earth? Thank you for exploring the true nature of flowers with me today. Keep asking questions, keep looking closer, and I'll catch you in the next explainer.